All right, and welcome back to another Math 1 homework helper. This is Unit 2, Lesson 10, Point the Way. All right, so we're going to go through and hit the ground running here. Very straightforward in today's homework helper. So in this first one, the first couple problems, it says make a graph of the function based on the following information, then write the explicit equation for the function. So it's going to be giving us a starting point. It says when x is 0, the y value is 5. Right then and there, that's telling us that we are going to have a y-intercept, 1, 2, 3, 4, 5, to get to there. It then says the y value decreases by 3 every time the x value increases by 1. So we're saying down 3 to the right 1. And so we're going 1, 2, 3 over 1. And because it's a linear equation, we're going to do it one more time, down 3 over 1. I apologize for that. And then we can just go through and graph. And I apologize, the board is not the best at draw our little arrows because it goes on forever and ever and ever. Now, with this, when it says, hey, we've got to remember to write the explicit equation here, you can just do that in y equals mx plus b. So when we look and we say y is equal to, if we're going down 3 to the right 1, it means that it's negative 3 over 1, which is just negative 3x. And then what was our starting location? Our y-intercept is positive 5. And there you have it. So we're going to blast through. We're going to do problems 2 and 4 as well. Very much set up the same way. We'll change the color here. So when x is 0, the y value is 16. Oh boy, well, we may have made a mistake there. So all of a sudden we're looking and we said, oh, we pre-drew our coordinates. That's never good. So we're going to go through and we're going to look and we're going to say, all right, we got to change this up a little bit. Give me a second. I'm going to update this board a little bit. All right, so during that little break, we went through, I updated this coordinate plane, created it so that it showed a little bit more room because it's dealing with an exponential. So when we look at this, it said at x equals 0, the y value is 16. So that means that we have a point all the way up there. The y value decreases by a factor of 1/4, which means we're taking our previous y value and dividing it by 4 every time our x value gains 1. So when x goes to 1, y is 16 divided by 4, which gets us to 4. Oops, sorry about that. So then when we move to 2 on the x value, we say 4 divided by 4, which is 1. To get there, sorry about that. Then if we were to go to 3, then we'd say, all right, well, now we're looking at 1 divided by 4, which is going to give us 1/4, which is not drawn to scale right there. And we start to see this curve here. So I'm going to go through and try to sketch this on here. I apologize. And then it's going to get really, really close there to being there. So when we go and we want to write down the equation here, remember that we're looking for, all right, what was our original, when x was 0, what was the y? And we know that that's going to be 16. Come on, board. So we're going to look and we're going to say y is equal to that original value, 16, times whatever our rate was. And we know that our rate was 1/4. We were dividing by 1/4, but we're just going to say we're multiplying by 1/4. And then that's going to be to our x power to get here. And this would be our explicit equation. So that's just what a graph would look like. Then we have what is our equation going to be. It's always what's that y-intercept times what's our rate to the x power. All right, moving on to the next problem here, which I believe is another linear equation, problem number 4. At x equals 0 and y is negative 8. So we went through, I gave a little bit more wiggle room because I saw that we were starting at negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. It's going to be right there. And then it's saying the y value increases by 2 each time that the x value increases by 1. So every time we move 1 to the right, we go up 2. So I'm going to say up 2 over 1. Up 2 over 1. And we could keep going with that, but we're not going to do that right now. To get something that looks like that. So just like in our first problem that we looked at, this is going to be a y equals mx plus b. We're going to go through, we're going to say y is equal to, we know our slope was 2 over 1, so it's just going to be 2x. And then our starting point on our y-axis was negative 8. So we plug in and go from there. Awesome. All right, scrolling right on down. In these next bunch of problems, use the given information to create an explicit equation. Your explicit equation should be in either slope-intercept or point-slope. Use the form that is most efficient based on the given information. I'm going to share with this right now. If you're doing point-slope and you have me as a teacher, I'm going to have it look a little bit different than this equation here. This equation's our point slope. I'm going to do a little bit different. I like having all of my y's on one side. I just think it's easier to kind of look at, even though it's easier to manipulate if it's in this newer version here. So if you have Mr. Marchioni or somebody else, they may have taught it a different way, but I'm going to be teaching it the way that I like showing. So with this first problem here, number 6, we're given a slope, we're given a b. If you're given that information, go plug in a y equals mx plus b and go home. So in this case, we're looking at y is equal to 3/8 x minus 3. Boom, done, move on. You have your slope, you have your y-intercept, call it a day. All right, so then we go to the next page here, and there's a bunch of problems up here at the top. Remember, we're looking for point slope or slope-intercept. Once again, problem 7 goes through and gives us a slope and a y-intercept. So we're going to go and plug right into y equals mx plus b. Y equals y equals 16. Come on. Y equals 16x minus 1/5. We're not worried about how ugly that would be to graph because it would be on not on an actual axis point, but ignore that. Then problem 8, we get to this point where we're given a slope and a point. Well, just plug in a point slope. So we're going to go through, we're going to say y minus our y value, which is -7, so plus 7, is equal to our slope times x minus the x value. And we can leave it like that. If your teacher's asking you to write it in a different way, just subtract your 7 over to the far side of the equation and you'll get the exact same answer. Or the same answer written a little bit differently. Better way of putting that. All right, we're going to go, what color have we used? We haven't gone pink. All right, problem number 9, slope and a point. Point slope. Let's go right back to it. We're going to say y minus 1 is equal to 2/3 x plus 6. Reason why it's positive 6 is because the equation is built with a negative sign in it, so it was minus a -6 to give us positive. So just be careful about that. And then we will go with our last one. We'll go with this wonderful green. We're given a slope, we're given a point, we're going to continue to use point slope in this case. So y minus 11 is equal to -5 x minus 4. Boom. And there you have it. Not any work, we're just plugging in. Don't overthink these problems. They're there just so that you can practice putting them in different forms. Problem 11 is asking us for each table of values, write 2 different explicit equations in point slope form. All that means, it's not asking you to think too hard, choose 2 points. So we're going to look, and I'm going to do this in 2 different ways. We're going to do, we're going to look at our pink one using pink, and we're going to do one using yellow. I'll try to get those colors to match here. So in pink, we go through and we say, all right, it says point slope. So we're going y minus 17 is equal to, we did not solve for what our slope was. So off on the side, we're going to go through and we're going to say, all right, it's our y's, the difference in our y's over our differences in our x's. We're going to say 11 minus 17, and you can do this with any 2 points that are up there, over, I'm just going to use the first 2. So 11 over 17 over 33 minus 32. It's going to give us -6 over 1, which is just -6. So we have a slope of -6 times x minus 32. There's one equation. Very little math, as you guys would put it, very little math with equations and whatnot to get us a correct answer. The original problem did say that we needed to solve 2 though. So then we're going to do the same thing down here. Luckily, we already did the difficult piece. So we have y minus a negative 1, which is y plus 1, is equal to, the slope stays exactly the same, times x minus 35. Even if you would have chosen 2 different points to check and see what the slope is going to be, because it's a linear equation, it's always going to have the exact same rate of change, so that slope's always going to be the same. So, cool. That one's there. We're going to go over to the next page here, to problem 13, which is asking us to do the same thing that we were just doing. We're going to look, first things first, because now I'm remembering, is that we have to go through and figure out what is our slope going to be. So if we choose these first 2 points, 21, 43 and 22, 34, I'm going to write them as y2, 34 minus 43 over 22 minus 21. This here is going to spit out, what, negative 9 over 1, which is just negative 9. I'm going to do the same thing that I did on the last problem. I'm going to highlight 2 different points here that we're going to go through and solve for what their point slope is going to be. So for this first one, I'm going to say it's y minus 43 is equal to the slope we just solved for negative 9. Well, x minus 21. And then we're done from there. Boom. For our bottom one, same thing. Y minus 16 is equal to negative 9 times x minus 24. And we're done. And remember, if your teacher taught this to always end up point slope having y equals and then everything to the other side, just take the extra number that's here or here or here. Just kidding. There we go. Or here. And add or subtract it over to the back side of the equation, and you're going to get the exact same thing. Sorry, as I clean up this. Apologies. Cool. All right. So moving on down to, to problem 14. For one of the tables in problem 11 to 13, show how the 2 equations you made in point slope form are equivalent. Just for the sake of things, we will do these 2 problem 13, just because it's right here. You're going to end up setting them both up again. We'll go pink here. We get y minus 43 is equal to negative 9. And this is the only time where I think it's actually way nicer to have it in the other form. Sorry, the screen is freaking out. That's a minus sign. And then over here, we're going to get y minus 16 is equal to, apparently, an enye. Come on. It's equal to negative 9 x minus 24 to get there. And then we're going to solve for each of them. We're going to go through, we're going to try to put these into slope-intercept form, so y equals mx plus b, which means we're just going to move everything over and do some consolidating over on the other side. So I'm going to go through and quickly do that. Y is equal to negative 9x. Oops. Plus 189 plus 43. Bear with me 1 moment so I can grab a calculator. All right. So when we go through, we get back here. Y is equal to negative 9x plus 232. All right. Great. We're going to hold on to that. Yellow, we get to go through, and we're going to do the same exact thing. We're going to say y is equal to, we're going to distribute the negative 9 to everything to get positive 216, but then with a positive 16 out there. And we combine some like terms. To get to here. And if you notice, both of those equations end up being exactly the same. And that's what we're hoping to accomplish, to show, hey, these are going to be the same regardless of what points we choose. When we get them to be slope-intercept form, they're going to be exactly the same. So we're going to go on to, I believe there's 2 more problems here. Sorry, my computer is being very pokey right now. All right, so show that the right side of the equation is equivalent to the left side of the equation. Justify each of your steps. Use the example to help guide your work. I am going to ask that you guys actually go through and show justification. I'm going to talk through that justification. Similar to any other video that I do, I try to hold off because of the board writing long sentences or anything like that. So what we're going to end up doing here is, let me zoom in so that it makes writing a little easier. We're going to look and we're going to say, all right, we're going to distribute our 2 to everything back here. So we're left with x minus 5 is equal to 5x minus 7. Please, please, please do not see minus 7 plus 2 and turn that into negative 5. The 2 is attached as a multiplication. Please follow PEMDAS order of operations. Make sure we're doing things correctly. But we get 6x plus 2 minus 10x. All right, so I'm a big fan of combining like terms all in one step. I like getting all my x's together. I like getting all my constants together and going from there. So in this step, I'm going to do all my justification out loud. Still have x equals negative 5. I'm going to figure out my x's. And I look and I say, all right, 5x plus 6x minus 10x gives me 1x. All right, cool. Negative 7 plus 2 gives me negative 5. And because of this, we go through and we see that we've got, we distributed, we combine like terms, then we use our commutative property of addition, similar like that we just did up in the example above. So that's all we're looking to do. Please write out your actual justifications on the right-hand side there. Our last problem, I believe, is problem 17. Which is located here. All right, so when we're looking here, we're doing the same exact thing. We're cleaning this up. So we've got 14x plus 2 is equal to, 2x is going to stay. We're going to distribute the negative 3. And we're going to get positive 12x plus 15 minus 13. So same thing we did on the last problem. I'm leaving my left-hand side alone. Let's just keep that there. And then I'm going to consolidate. Luckily for this one, it's all of our x's are next to each other. All of our constants are next to each other. 2x plus 12x gives us 14x. 15 minus 13 gives us positive 2. So once again, justification, distributing. Then we combine like terms, and then we use our commutative property of addition. Cool. All right, so that does it for another episode of Math 1 Homework Helper. If you got questions, please go talk to your teacher. If not, have a very, very